Okay, this is the second video on C pointers. This is the time we're going to be looking at structs slash actual pointer utilization to save memory. So let's include our standard library, stdio.h. Now, if you are coming from another language, something like Python, C++, or Java, or anything that supports classes, and you don't really know where to do, just do hashtag define class struct. Now, we can use struct, but also, instead of that, you can just type in class if that's what you're more familiar with, as if we go to here, expands to struct. So it would be directly the same, just different syntax. So let's have a struct called player. Now in this, let's just make a score. That's it. And you need to put a semicolon at the end here because it's not a function or our main. So it needs a semicolon. Now let's make a function called update. It will take in a player struct. Now pointer, you can name whatever you want, so let's just go pointer player. And then we take in a score as argument. So here's where the syntax gets a bit weird. P player dash less than score equals score. And that would be it. So this of we know is our pointer. This, it points to the score here, and this, it points to the score in the arguments, so it makes the one in the struct equal the one that we put in for an argument. If we just change this to points, it'll throw an error, points, just to sort of differentiate a bit. So let's make our main void, because we take in no arguments. And by the way, void is unneeded. You can just do that. It's the same thing. So struct player. What should it be called? It should call player 01. So let's call it update. And link this pointer to the one that we made here. So player 01, and our points will be made into our score. So let's say 20. So now let's printf %d because we're printing out a number, and our player 01 dot score. So the dot here is just an attribute accessor. This is an attribute. So we have the main thing here, the main name. We use it. We gain access to its attributes through the dot. Put in score. And you will see a lot of people do return 0. You don't need to, it's optional, but most modern compilers will do this automatically because this is an int, meaning it will return an integer. So most people say return 0 for success. It's unneeded. You don't need to write it. So let's compile this. Screen 20. But how does this work? I have made this brilliant example here. So in our first memory address, we have our variable or data, or in this case, our struct here. And in the second one, which is where we use the pointer, so this would be the first one in our memory address, and this pointer would be here in memory address 2, but instead of having and copying the data over to the second one, it will be the first one being pointed to. So that's how it saves memory and keeps the size of our .exe file down.